Hello everyone and welcome to this video. So in this video we are going to discuss a simple way, okay? So it's good especially for beginners if you don't know or you don't have any preference which machine learning model you need to choose, okay? So this is a very common problem, okay, where sometimes you need to try multiple machine learning models. So maybe you need to try XGBoost first and then maybe decision tree, multi-layer perceptron, linear regression, and so on. So I'm going to give you a simple way that could give you maybe, the first steps or the first initial step where you can start from. So I'm going to discuss in this video a library called LazyPredict, okay? So I'm going to attach in the description all the necessary links that you might need. So the library will be divided into two things, okay? So we can use it for both classification, and regression, okay? So let's use it also for regression, okay? Now, why this library is really special, and I like it, to be honest, personally, I like it so much and I use it till now because it's really very easy, very simple, doesn't take time, and you can directly know which model you can work on and maybe which model you can start modifying and so on, okay? So let's start first by the dataset. So we are going to use a dataset from Kaggle, a simple linear regression dataset called salary dataset. So you can see that the dataset consists only of a column called years of experience and another column called salary. So this is basically a dataset that will be output the salary based on the years of experience that this person have. Okay, this is a very simple data set, and from the description you can see that simple linear regression is the best, or maybe one of the best models that could be used here. But what we're gonna do here is we are going to try to see multiple models on the same data set. Okay, so let me first install the important libraries. So need a code here. So we are going to install pip to get the dataset. Install open datasets dash quite, so we don't get any disturbing outputs. And we are going to write od.download. We need to import it first. So import open datasets as od and od.download and paste the link. Now we are going to download this dataset directly from Kaggle, and I'm going to attach a link in the description on how to get the username and how to install any dataset from Kaggle inside Colab. I already did this video some time ago, so you can check it. For now, this is out of the scope, so I already have the username and the password, so I pasted it and that's it. So here we have the dataset. Okay, now let's try now to see how this thing will work. Okay, so first of all we are going to install something called pip install LazyPredict dash quite also. Okay, and we're going to install this thing now. Okay, so we are good. I believe we are good. Okay, now in the regression example, it's very simple. It's way simpler than you think. So in the regression example, you're going only to write from LazyPredict.supervised import lazy regressor. So we are going to deal with something called lazy regressor. So you see here, it has both things, lazy regressor and lazy classifier. Both works almost the same way. We're gonna show that in the video as well. Okay. And then let me disable the AI tools so that we can, to avoid any confusion. We are going to close them for now, okay? And we're going to get sklearn dot probably, I'm not sure, maybe we can get metrics import classification report, okay? And from train we are going to get sklearn.model selection import, I think train test split it's called. So yeah, this one. Okay, so better to split the dataset for us. Okay, now we are going to use this. So what does this return? sklearn, it will return for us the x train, x test, y train, y test in this order. Okay, so we're gonna copy paste them here. But first, before we do anything, we need to import pandas as pd and then we're going to read the data set. So data is pd.read CSV, and we are going to read the data set from here. So we're going to copy path and read this here. Okay. Now let's first see if this if everything is working fine and the data set is as expected. So we have everything here. So first of all, what we need is only these two columns. So the first one is called years experience, and the second column is salary. So these two things only we need. Okay. Of course, you can okay, so probably there is a typo or something. So let me wait. I think there is a typo, so let's try to see this again. So years of experience and salary. Okay, when you choose columns only, you would put double brackets, not only one bracket. Okay, my fault. Now, of course, you can do exploratory data analysis. You can understand the things, the distributions, all of these things you can understand and you can do. And I'm not saying that these are not important or less important. They are very important. I'm just saying that if you don't really have preference which machine learning model you can use this library. So let's split the data. Xtrain, Xtest. By the way, I'm going to attach this. I'm going to put this notebook in GitHub, and you can, and I'll put the link in the description. You can go and check it out if you want. Okay. Now we are going to provide the first input first, so which will be the years of experience. Then we are gonna provide the output, which is salary, and then we are going to put test size is equal to 0.3. Let's split to 70-30. Okay. Now split. Okay, we are good. Now we are good to go. These both are numeric. We will not do any pre-processing. The purpose of this video is to show you the library LazyPredict and what is it capable for. Okay. I'm not saying again any of the normal traditional steps are less important. They are very important, but this step could save you some time and could give you more clarity on which model is best in for your data set. So let's call it reg or regressor maybe, and we're gonna call it and we're gonna write here lazy regressor. So we are going to write verbose is 0, and we are going to write something called ignore warnings equal true, so we don't want any warnings, and we're going to write a custom metric equal what? Equal none. And I'm going to show you this custom metric how it works. Okay, now let's run this. Okay, it's done. Now we can run something called models comma predictions. So we are going to check now our models equal regressor.fit, and inside the fit function we are going to put xtrain comma xtest ytrain and ytest. Okay, and that's it. Now let's try to see what will happen after we run this. Okay, so yeah, so this is a series, and that's a problem. We need to convert it to numpy array or list. So we're gonna write here np.array, and we're gonna write here also np.array. Okay, so it only works for numpy arrays for now, or sorry, it doesn't work with pandas, it works with numpy and I believe lists as well. So let's try to run everything again. Now it doesn't take time. There are some warnings that will show up even though we are having ignore warnings as true, but these are related only to one algorithm, which is light GBM. It has specific requirements, so we can ignore them and we can go and see the rest of the models. So these are warnings, so we want to see the models. So let's clear this and let's write a new cell, write init models. Here you go. So you see how many models were generated from this. So you see a lot of models. Okay, so in just a couple of seconds you have extra tree regressor, extra trees regressor, bagging regressor, Lars, lasso. You have a lot of other gradient boosting, XGB regressor, k-nearest neighbor. You have some others as well. You have, I think, linear regression somewhere. You have linear support vector regressor. So you have everything here. and it comes with some parameters. So it gives you the time taken for each algorithm to be trained. So you can see, for example, random forest regressor takes the longest, I guess. So yeah, and it has R squared and adjusted R squared of 92% and 91% and root mean square error. What if I want to include one more metric? These are not enough for me. Let's say I'm using a use case and I want to target one specific metric, not these two. So now we can use custom metric. So it's used as none now, but what we can do is that here scalar.metrics, we can also write, let's say we have what here? We have root mean square error. So I'm gonna say mean absolute error. Okay, I just want to use this one. And I'm gonna copy this one and put it in custom metrics. And let's try to run this again. Let's see what will happen. Now these warnings, we're gonna ignore them. And here you see that mean absolute error is also calculated for you. So you can judge the models from here. And these things are using the default parameters of the model. So let's say extra tree regressor. If we go to extra tree regressor, for example, just an example, it uses these parameters, the default ones. It doesn't change anything in them. So what you can do is that you can maybe, let's say I'm going to use extra tree regressor, which achieved 94% of R squared, and maybe I'll edit a little bit here to get better accuracy if I can increase it more. Okay. Of course, this accuracy could have been better if we went through some data pre-processing, but yeah, we didn't do that. So this is only for the purpose of saying the LazyPredict. Okay, so I think you got a good idea about LazyPredict in regression. Now let's try to see how it works for classification. Okay, now classification is almost the same. Okay, there is nothing complicated about it. So we're gonna write od.download also. We're gonna write the same. And we are going to download this dataset. It's called the mobile price classification. Now this is a bit complex dataset. So I guess it would take more time because we have here 21 columns, or let's say 20 columns. And the last one is for the price classification. So the price here is not a regression, or not a numeric, it's just 0, 1, 2, 3, which stands for low cost or medium, high, or very high cost. Okay. Now the dataset is already split. We are going to use the train. This dataset I think was used for a competition, so they don't have any preferences in the test, but we're gonna use the train for now, and we are going to see how this will work. This is a bit complex dataset. Okay, so this could take a while, but okay, let's try it. Okay, now let's go again to the get the link copy, or no, wait, let me first put it here, and then let me get my credentials, so my username and my password. Okay, again, in the description you're gonna see a link on how I get these credentials. This thing is completely free, guys. Okay, so don't worry about it. Now let's try to see the dataset. So we have a trained dataset which we are going to take. So import pandas as PD, and we are going to write data is equal to pd.read CSV, and we're going to paste this here. We are going to take also a couple of things from here. So let's take all of them and filter them out. Okay, now we will not take pandas again. I think we can use NumPy, so let's keep it. We'll not use mean absolute error. In this case, let's say, I'm not sure, maybe F1 score, let's say. Okay, just an example. Okay, and instead of lazy regressor, we are going to write lazy classifier. Same idea, guys. Okay, so nothing complicated. Let's run this, and we are going to now check from previous code what we are going to use. We are going to take this one. So before this one, we need to, first of all, let me visualize the data. So data.head, and we will need to use the following. So x is equal to data of what? Now we are going to take all rows, and we are going to take everything except the last column. So like this till -1. Okay. And for y, we're going to do something similar, all rows, but only the last column. Okay. Now let's try this and let's see if it works well or not. Now let's try x.head. Okay, so there is a mistake here. think it's double. No. So let me see, slice none. If we didn't specify anything, okay. Yeah, sorry, I forgot that. So I should specify here dot iloc, and this not only data, so dot iloc. Okay, now you see that X is working fine and Y is also fine. So we can proceed with that, okay? Now we will go here into xtrain, xtest, and so on, these things, and then we are going to write, instead of this, we're going to write X as a NumPy array and Y. Okay, it worked. Now the next step is to use the lazy classifier. So let's write here classifier is equal to lazy classifier, and in lazy classifier we're going to write the same. Verbose is 1, ignore warnings is true, and we're going to use a custom metric as F1 score. Let's try that, F1 score. And let's try to get models, comma, predictions. So pretty much the same. And this will be classifier dot fit. And we're going to provide all of these things again like before. And let's try to run this. Now let's see how this will work. Okay, error. So why there is an error? All arrays must be the same length. Okay, so probably there could be some missing values, I think, that we ignored. So let me check data.isNA.sum. Again, guys, there is a pre-processing step that we must do. I'm ignoring it for now because this is out of the scope. Okay, so do we have any missing values here? Okay, we don't have missing values. So I think the order of these details is different. So xtrain, xtest, ytrain, ytest. And we took X and Y here, so okay. Now I think there is something. So let me try to print X.shape and print Y.shape. So let's see. Okay, so we have everything complete. I don't know, but I think there is something wrong with this NumPy array, so let's remove it. Probably because we have already a multi-dimensional pandas, not a series. So let's try again. Okay, so this is not default. Okay, probably because of the F score. I don't know, but I think could be because of the F score. So yeah, F score requires to be a different type of encoding. So we'll ignore that for now, and we will check the models. Okay, now let's try to check the models, and we got all of these things. Okay, so it's already calculating the average F score. Okay, not for each class. And we have the following, guys. So we have models, logistic regression. So the logistic regression has got us the highest accuracy and got us also very good F score, and it took less time. You can see that the accuracy is sorted from bigger to smaller, okay? So if you go down, you can see dummy classifier, label spreading, label propagation. These are very bad classifiers in terms of results, and these are the top ones, okay? Now, this would give you a very good idea about which model you can use. So if you choose model of 0, sorry, it's not a list. Let me try to check with you classification report of predictions together with Y test. Okay, so let me check predictions, how it looks like. So this is, okay, so this is the predictions. Okay, so we cannot extract really the values, so I'm not sure if we can do that. Yeah, so we cannot extract the values. But what we can do now, okay, is that we can check out something, is that we can use logistic regression directly from the scalar. So you can import directly as a logistic regression from scalar, and you can then start from here and see the detailed accuracy, F-score, classification report, and all of that. So yeah, this library I discovered it recently, so I wanted to share it with everyone. I'm going to post all these necessary stuff on GitHub, so if you want, you can explore them. I'm going to also to post the links to the dataset and the video where I got the credentials of Kaggle, which is completely free. Okay. Thank you very much for watching. If you are interested in this content, please feel free to subscribe. And yeah, thank you very much.